So this is an exercise called betting with physics. The first question I always get is betting legal in school? And the way I explain it is that in this case, yes, betting with your grades and in school and in a classroom is legal because it's not really betting if you know what you're doing. So, we're going to say hi to the cat. So, what we're doing here is that we are doing a demonstration with different sized objects rolling down a ramp, and the objective for the students is to predict which objects will roll down soonest. So at this point in their physics semester, they have already gone through the topic of moment of inertia. So using this concept, they should have memorized already different values of moment of inertia for different shaped objects. So some of those objects we're using here today. So the first one is a soccer ball or a hollow sphere. Then we also have another solid sphere, or we have another sphere that is solid, okay? A secondary solid sphere. This is a lacrosse ball. This first one is it's a foam squishy, like a stress ball. Okay, but it's still the same density throughout, so it is solid. We would consider that solid. And then this is just a roll of shipping tape, but we would call this a hoop because most of the mass is along its edge. So what we're going to do here is the students they all start off with 10 points, and they can bet along the way. Each time they bet, they can either lose or gain that many points. So they start with 10, and the goal is to get upwards of 40. They can get as many as 50, so the students can wind up getting 50 out of 40 points. So some extra credit opportunity there for the students. This tends to actually get kind of loud and exciting, and the students get really disappointed if they don't predict correctly. But again, I remind them that they should all be able to predict correctly because we've already covered these concepts. So the first one that I'm going to do, I kind of just pick these randomly, but I'll go ahead and start with, let's do the hollow sphere, the soccer ball, and then also the lacrosse ball. Okay, so these are two good ones to pair. So the main thing here is that you need to start the items at their center of mass so that it's basically measured on how the center of mass, or when the center of mass reaches the end of the ramp, not the edge of the ball. So we want to start them evenly, okay? So, and you can kind of tell usually based off just kind of looking at them when they finish. Every now and then you'll have to run a couple trials because you may not start them at the same point, okay? Or maybe you don't release your hands at the same time. So that can affect the results. As the teacher, you should be able to know the outcome ahead of time as well as should the student. Okay, so these look like they're lined up pretty well. Okay, so my prediction for these, let me think about the equation here. Let's see, and okay, so I believe that, let's see, 2/3 and 2/5. Okay, so I believe that the solid sphere, this lacrosse ball, will finish first. Okay, and so beforehand also I would have like passed around the different objects to the students. They can like inspect the board, make sure there's no funny business going on, no magic, right? So I'll let them inspect the materials as well. But off the bat, like they would be able to tell that this one is definitely heavier than this one, okay? But this is obviously much larger, has a larger radius. So usually I don't even clue them into those things, but they'll come up with those on their own, and sometimes they can get thrown off as well. So here we go. 1, 2, 3. Okay, so as you can see, that solid sphere, the lacrosse ball did finish first. Okay, so then I just collect the materials. Usually there's a nice student that will collect them for me as well. So you could also do this in like a slow-mo replay when they finish at the end. But it's usually good enough to just kind of see it with your naked eye. So that was round one. So then I would get two different objects. All the students at this point would have either gained or lost points. Hopefully gained. And we're going to pick two different objects, or a different pairing. So now, so I just did the solid sphere with the hollow sphere. So now I'm going to do the, let's see, actually let's do these two. Okay. Lightweight foam ball compared to the denser lacrosse ball. Okay. Somewhat similar in size. Okay. This one is a little bit larger in diameter and radius. However, this one is definitely probably about 3 times heavier, so greater mass. Okay. And I'm only saying that because most of the students will ask those things, so giving that to you as well. So again, you just start this at the same point on the board. Try and line up the center of masses and let them run. 1, 2, 3. Okay, so the solid sphere on that one looked to me like that one finished just a tad sooner, but this also might not be completely level, but they should finish at the same time. And so this is when some of the students kind of have some cognitive dissonance happening and they don't understand why they both finished first, because one has a much greater mass than the other. So if the students got that wrong, then that's an opportunity for them to start figuring out, okay, why did I get that wrong? And if I'm basing my predictions improperly, then I need to reassess and readjust how I'm predicting and how I'm calculating my results. Okay, so round 2 is done. So let's go ahead and do the hollow sphere with the hoop. Okay, so let's see. Oh, I didn't make my prediction there, but that's okay. But they both finished first, or at the same time. So with this one, again, you gotta line these up correctly. Okay, center of mass. Okay, not the front edge, but the center of mass. Because we want to know when the center of mass reaches the end of the board. Okay, so let's see, do my prediction in my own head. So we have, and we have this one. So I believe that the hollow sphere, even though this has is much, well, this one maybe weighs a little bit more. I don't have a scale with me, but so maybe about equal mass actually. But anyway, I believe that the hollow sphere, the soccer ball, will finish first. And 3, 2, 1. Oh. And that's where you get a bad trial, because they actually ran into each other. So let's try that one again. Okay. And let's see if they're lined up. And this is where you would usually ask the student to help you, student to the side, to see if they're lined up properly. 3, 2, 1. Oh, and I made a bad prediction. And that happens. Okay, so I would have lost points on that as an example. So students would then have to figure out, oh, why did that happen? And keep readjusting. Okay. So then the fourth one, what I'll probably do is, let's see, we'll get a different pairing. We'll do the hoop and the solid sphere. Okay, so the hoop and the lacrosse ball. So you do this like this, okay? And you let them run again. And you as a teacher, right, shouldn't be making the predictions out loud. You can do that in your head, because otherwise if you predict if you're giving away the answers, that doesn't really help anyone. Okay, so 3, 2, 1, go. All Alright, and the solid sphere won. And so this is when the class gets really loud because now it's over, and they're tallying up their scores. And a lot of people will have, you usually get a wide range of scores. So you have people that are like way above the maximum because they just kept betting all of their points over and over again because they knew exactly what was happening. And then you'd also have people that are really low in points. They bet all their points, or maybe they bet too many at the first point at the first run, and they didn't know what was happening, and so they only had like maybe 1 or 2 points left to bet, and so they even if they got the rest right, in terms of their predictions, they bet too much too soon, and so they could only get so many points back. So this is an example of, you know, how being conservative sometimes can help with that sort of thing. But there are other opportunities to get points back. So this isn't such a, even if they do really bad, this isn't like a huge boon to their grade. But so the primary objective of this is to connect the ideas for them between their moments of inertia of different objects and the angular speed of the ball and how that relates to angular momentum. So you have your angular momentum equation, and it's L is equal to I omega. So if you have a hollow sphere with a moment of inertia of 2/3 mr squared, and you have a solid sphere with a moment of inertia of 2/5 mr squared, since the solid sphere's moment of inertia is less, that means that its rotational velocity is going to be greater, like so.